By the end of this lesson, you should be able to determine the relationship between pressure and volume at constant temperature for a fixed mass of gas. That is, PV equals to constant. Does the boy find it easy to push in the piston? As the boy pushes in the piston, he finds it more and more difficult to push the piston further. How does the pressure of a gas change with its volume? To compress the air in the cylinder, the boy needs to exert a force, F, on the piston. If the cross-sectional area of the piston is A, then the pressure exerted on the piston in the cylinder is P equals to F over A. How far in will the piston move? For a particular force, the piston will move as far in until the pressure of the air inside the cylinder equals to the pressure exerted on the piston. Drag and drop the loads to the piston. Observe how the molecules behave when loads are added. When the loads are added, the volume of the gas decreases. The number of gas molecules per unit volume therefore increases, and there are more collisions with the walls of the container. Since the frequency of collisions with the walls of the container increases, there is a corresponding increase in the pressure of the gas. Let us now study the relationship between the volume of a fixed mass of gas and its pressure while maintaining the temperature of the gas. During this experiment, no gas can enter or leave the cylinder. By keeping the temperature of the surrounding constant and by slowly pushing in the piston, the temperature of the gas is kept constant. The volume of the gas, V, is decreased by pushing in the piston. The pressure of the gas, P, is recorded from reading on the burden gauge. Next, we plot the graphs of P versus V and P versus 1 over V. The graph of P versus V shows that when the volume of the gas is small, its pressure is big. But when the volume of the gas is big, its pressure is small. The graph of P versus 1 over V is a straight line through the origin. From this, we can conclude that P is directly proportional to 1 over V. We can also say that P is inversely proportional to V. In mathematical terms, P alpha 1 over V or PV equals to constant. Hence, the pressure of a fixed mass of gas is inversely proportional to its volume when the temperature of the gas is kept constant. This is known as Boyle's law. Boyle's law may also be depicted by the graphs. The straight line graphs show that the product PV is always constant. Observe the air bubbles formed at the bottom of this aquarium. Why do the bubbles increase in size as they rise to the surface? We can use Boyle's law to explain this phenomenon. Let the pressure of an air bubble at the bottom be P1 and its volume be V1. Let the pressure of an air bubble at the surface be P2 and its volume be V2. From Boyle's law, PV equals to constant. That is, P1 V1 equals to P2 V2. That is, V1 over V2 equals to P2 over P1. Nearer to the surface, the water pressure decreases. Hence, the air pressure in the air bubble decreases as the bubble rises up. That is, P1 is greater than P2. This means P2 over P1 is smaller than 1, and hence V1 over V2 is smaller than 1. Therefore, V1 is smaller than V2. Hence, the bubble increases in volume as it rises higher in the water.